right, so we say a function is right continuous if the limit as x approaches a from the positive side of f of a is equal to f of a. What we're talking about here, the big difference, all of the other pieces hold true, except for now we're just talking about a limit from the positive side. So if I have two values of x, a and b, the function would look something like this for it to be right continuous. So remember, we're coming at a from the positive side, from the right side for a, and as I'm doing that, that limit exists and it is equal to the function value at that point. So this, we say, has continuity from a to b. Now notice b is not included. If I want to look at the next graph that we would say has left side continuity, we look at the same thing. We have a and b, only the b side would be closed in. And what I can say with this is that the limit as x approaches b of f of x is equal to f of b. Now, what side does this happen on? This happens on the negative side. Why is that? Because we are coming at it from the left. So from the function from the smaller side of b is coming at this way, and from this way it works. So this is continuous on the interval from a to b. Now let's go ahead and try an example with that. I'm going to go ahead and graph this because I do think the graph of this function will help us. When we are graphing a piecewise function, let's first look at x squared plus 2. Now this is only for the values where x is less than or equal to 0, so it only has the values over here on the left side where it is negative. All right, I know that is a parabola and it has been shifted up 1 by that x squared plus 1, so I'll go ahead and start right here at 1. I know this is filled in because this is x squared is less than or equal to 0, so that's a filled in point. And the next value that I would have, let's go ahead and plug in that value of 1. 1 squared is 1 plus 2. So my second value would be up here, and I'll just go ahead and sketch that graph in. All right, the next one that I have over here is a line that is 3x plus 5, and that is where x is positive. So all of that happens over here on the right side of my graph. Now, if I am looking at this function, I know this is my slope and y-intercept. My y-intercept is up here at 5. So I'll go ahead and put that in. Now, as I'm looking at this function, this only happens where x is greater than or equal to 0. So as I draw that in, I need an open circle here, and that slope is 3. So I'll go up 1, 2, 3 over 1, and then I'll draw that line. All right, so the picture does help, but at the same point in time, the limit is also what we need to know here. So what is f of 0. That's going to be really important. Now, f of 0, what happens is, where do you plug it in? You plug it in where x is less than or equal to 0. So you plug it in into the first part of this. So f of 0 in this case is just equal to 0 squared plus 1, or equal to 1. So let's look at the left and right side continuous at 0. So if I look at the limit as x approaches 0 from, all right, so let's take a look at the limit of 0, and we need to take a look at that limit of 0 from both the positive side, and the positive side is, remember, the right side. And we also need to take a look at this as the limit as x approaches 0 from the negative side. All right, of the function. All right, so positive side means I'm coming in from the positive towards 0 from the right, and this gets closer and closer to that value of 5. Now, as I'm coming at 0 from the left, from the negative side, that gets closer and closer to this point, which is 1. Now, as I look at this, remember, for it to be continuous, the limit has to equal the f of x value. So this is no, and this is yes, because the 5 does not equal 1. The 1 is equal to 1. Now, what I would say for this, and how I'd write where the function is continuous, I would say the function is continuous from negative infinity to 0, continuous at 0 from the left, but from the right, it is not continuous, and it goes all the way up to infinity.